Let's continue with the examples. If you look at the lecture note, then I wrote 7 formulas. I think you have to remember all of those formulas, but if I copy all the formulas, then it'll take too much time. So I will just jump into the problems. When I solve the problem, I will introduce you the formula or remind you of the formulas. If you look at the lecture notes, those are about e to the x and the sine of x and cosine of x and natural log of 1 plus x and the tangent inverse of x and so on. Those are described with a Maclaurin series expansion. So this part, look at the lecture note. (6.38a). Find the first 4 non-zero terms of the Maclaurin series. So f of x equals 3 times e to the 4 x to the 5th power. What we will use will be the Maclaurin series expansion for e to the x. That is summation n equals 0 to infinity, x to the n power over n factorial. As I said, you have to remember this. Let's do the expansion. That is 3 times e to the 4 x to the 5th power. So 3 is just a multiplied constant number. And we will think about this part's expansion. That is summation n equals 0 to infinity. X was the power. Power is 4x to the 4th power. So 4x to the 4th power to the n power over n factorial. The problem is the first 4 non-zero terms. So that is 3 open parentheses, 4x to the 5th power, 0 power over 0 factorial, plus 4x to the 5th power to the 1 power over 1 factorial, plus 4x to the 5th power squared over 2 factorial, plus 4x to the 5th power, 3x to the 5th power, 3 power, 3 factorial, and so on. So when we go further, just this part is just 1. So 3 open parentheses, 1 plus this is 1. So there's nothing. So 4x to the 5th power plus this one equals 2. So it becomes 2. I think it is better not to be tricked. And so this is 2, 16x to the 10th power. I did this. Plus 3 times 2 equals 6. And I do distribution with power. That is 64 x to the 15th power over 6 plus da da da, right? And so I think this one is 8. And this one is, what is this? 3 and 32, right? So the first 4 term of the Maclaurin series will be obtained by expanding out this way. So this is 3 plus 4 times 3 is 12, x to the 5th power plus 8 times 3 is 24, plus this one will cancel each other. So x to the 10th power plus 32 x to the 15th power, right? 1, 2, 3, 4. Any question? Let's do the second problem. The second problem is f of x equals natural log of 1 minus x to the 4th power. We will use the formula natural log of 1 plus x equals summation n equals 1 to infinity, negative 1 to the n plus 1 power, x to the nth power over n. Again, this is something you have to remember. Things are looking pretty similar. So it is better to write the formula sheet and repeatedly look at the formulas so that you're not confused with the formula. Natural log of 1 minus x to the 4th power is given. We want to use this, so we will convert the format. Looks as if that is in this formula. So I would write plus negative x to the 4th power. So that equals summation n equals 1 to infinity, negative 1 to the n plus 1 power times this one, this part became negative x to the 4th power. So negative x to the 4th power, n power over n. So let's expand that out. This time it starts with 1. So negative 1 to the 1 plus 1 power, negative x to the 4th power, 1 power, 1. Plus the second one is negative 1 to the 2 plus 1 power, negative x to the 4th power squared 2. Plus negative 1 to the 3 plus 1 power, negative x to the 4th power cubed over 3, plus negative 1 to the 4 plus 1 power, negative x to the 4th power fourth power over 3, and so on. But the answer will be just about the first four terms. So it is enough to simplify the first 4. This one is 1 because second power. So this one is negative x to the 4th power minus, because this is cubed. And then this one is distributed in this way. Negative 1 squared is 1, x to the 8th power over 2. And then this part will be 1 because 4th power. And we distribute it. And then negative 1 cubed is negative x to the 4th power. Cubed is x to the 12th power over 3. Then this part will be negative 1 because this is odd degree power. And then you distribute the power, and then negative 1 to the 4th power is 1. So x to the 16th power over 3, it is 4. And so on, right? So the answer about the first 4 terms is this one. Any questions? Let's do the next one. Next one, maybe a little bit more complicated, but we think about the integral technique when we approach this. There's something similar to integral technique, even if we don't use integral technique here. The problem is f of x equals 2 times cosine squared of 4x. What we will use will be, what we know is cosine of x equals summation n equals 0 to infinity, negative 1 to the n power, x to the 2n over 2n factorial. Cosine is an even function, and this is the formula, even degree power. And the problem is, this is cosine squared. And so if you think about squared, this is an infinite series, and the same thing is multiplied, and you will do something similar to FOIL. You will do distribution, and then it'll be too complicated. So what we will do will be, we will use the half angle formula. So cosine squared of x equals 1 plus cosine of 2x over 2, right? So in this case, we will use the 2 formula. I will apply this formula first, and then I will apply this formula. So this one is 2 times cosine squared of 4x. So that is 2 times 1 plus cosine of 2 times x became 4x over 2. So if you cancel it out, and then that is 1 plus cosine of 8x. So after we lower the degree by using the half angle formula, we can easily apply the formula which is already established. So we can expand this out with 1 plus summation n equals 0 to infinity, negative 1 to the n power times 8x to n power over 2n factorial. We are thinking about the first 4 terms. So let's do it. This is 1 plus, we will think about the first 4 terms here. And n start with 0. N equals 0, so negative 1 to the 0 power. 8x 2 times a 0 power over 2 times 0 factorial plus negative 1 to the 1 power times 8x 2 times 1 over 2 times 1 factorial plus negative 1 n equals squared. So 8x 2 times 2 over 2 times 2 factorial plus negative 1 cubed 8x squared cubed, because we are replacing n by 3, 2 times 3 factorial plus da da da. Here, everything is a 0 power, or 0 is multiplied in factorial. So this part will become 1, right? And so this is 1 minus, this is 2. So 8 squared times x squared over 2 plus this one is 4, this one is 1. So 8 to the 4th power times x to the 4th power over, this one is 4 factorial, minus this one is minus because negative 1 cubed, and then this one is 6. So 8 to the 6th power, x to the 6th power over 6 factorial plus, and so on. So I missed this one, I dropped this one, so I have to write 1 plus. So this one is 2 minus, if you, this is 64, so 32 x to the x squared. Plus, if you simplify this part, then you will get 512 x to the 4th power over 3 minus, again, you have to simplify this part, then it will be 16,384 x to the 6th power 45. So I think no, you have to use calculator for that fraction part. And this is the answer. If you look at the lecture note, and then there are examples about inverse tangent and hyperbolic sine. You have to go through those problems also, but let me move on to the next pattern of the problem. The problem is very similar. Problem is just find the first 3 terms of the Maclaurin series. The way we approach the problems will be different. So f of x, the problem is f of x equals 14 x to the 6th power e to the 2 x to the 7th power. For this particular problem, I believe if you just use e to the x equals summation n equals 0 to infinity x to the nth power over n factorial. So for this particular problem, I think the easier way to go is you just get the Maclaurin series expansion for this part and then just distribute with x to the 16th power. So I think that'll be easier way to go, but I think Newton Alta is wanting you to use a different technique. And so I will introduce you how you can approach that problem as Newton Alta's the pedagogical philosophy reflects on this problem. And then I will just try to approach directly. So what Newton Alta is the author of the problem was thinking was for this part, if you look at this and then e to the 2x to the 7th power, and if you differentiate this part, then you will get this one. So that is resembling the chain rule of e to the 2x to the 7th power, right? So what we will try to do is, let me say method 1. Is we just integrate it first as 14 x to the 6th power e to the 2 x to the 7th power dx equals, so we think about the substitution method. So u equals 2 x to the 7th power and du equals 14 x to the 6th power. And so e to the u du, right? This one is du, and this part is e to the u power. So what can you say about this? It is e to the u plus c equals e to the 2x to the 7th power plus c. So as I explained, what would happen will be if you differentiate this part, e to the 2 x to the 7th power, then you would get 14 x to the 6th power times e to the 2 x to the 7th power equals f of x, right? So what we can say about f of x is this one. F of x is given as 14 x to the 6th power times e to the 2 x to the 7th power, and we can regard that as the derivative of e to the 2 x to the 7th power. So that is ddx. So summation n equals 0 to infinity. We are using this formula. Instead of x, we will write 2x to the 7th power. So 2x to the 7th power n over n factorial. So that is a convergent sequence. So that is summation n equals 0 to infinity ddx 2x to the 7th power n power over n factorial. So we can rewrite that as n equals 0 to infinity ddx. Before we differentiate, let's make things a little bit clearer. 2 to the n power, x to the 7 n power. Here, 2 is a number and n varies, but what we are doing is just differentiating according to x against x. So all those other numbers are just constant, and then it becomes summation n equals 0 to infinity 2 to the n power times 7 n times x to the 7 n minus 1 over n factorial, right? So all we have to do is expanding out. So n equals 0, then 2 to the 0 power, 7 times 0. Times 0 to the 7 times 0 minus 1 over 0 factorial. And so, of course, that'll vanish. Plus 2 to the 1 power times 7 times 1 x to the 7 times 1 minus 1 over 1 factorial plus 2 squared 7 times 2 x to the 7 times 2 minus 1 over 2 factorial plus 2 cubed times 7 times 3 times x to the 7 times 3 minus 1 over 3 factorial plus and so on. So this one will vanish And 1, 2, 3, we have to write 3 non-zero terms. And so this part will make 14. And this is 1, this is 14. This is a 1, and this is 6. And so the first term is 14 x to the 6th power plus these two will cancel each other. 4 times 7 will make 28. So 28 x to the 13th power plus just if you calculate further, this one is 3 times 2, right? This one will cancel each other. This one will be like this. So 4 times 7 is 28 x to the 20 power and so on. And the answer is this one. As I said, the Newton-Alta's expectation is going through the integration and differentiation, and that's the main purpose of this problem. But I think the easier way to go, at least for problem solving, will be just we keep this part as it is and use this part expansion. Okay. So we have f of x equals 14 x to the 6th power times e to the 2 x to the 7th power. And so what I'm saying is that we just expand this out and then we think about the distribution. So we have 14 x to the 6th power times summation n equals 0 to infinity x to the n power. This is x. So 2 x to the 7th power n power over n factorial, right? And then, so let's do this. And this is 14 x to the 6th power summation n equals 0 to infinity 2 to the n power times x to the 7 n power over n factorial, right? We did this. And so this is 14 x to the 6th power. Open parenthesis, we start with 0, 2 to the 0 times x to the 7 times 0 over 0 factorial plus 2 to the 1 power x to the 7 times 1 power over 1 factorial plus 2 squared times x to the 2 times 7 times 2 over 2 factorial. Let me do one more. 2 cubed 1, 2, 3 times x to the 7 times 3 over 3 factorial plus and so on. So what is this? 0 factorial is 1. This one is 1 and 0 power is 1. And so let me just do one more step. So 14x to the 6th power. This one is 1 plus this is 1, and so 2x to the 7th power plus this is 2, this is 4, so they will cancel each other. That is 2 to the x to the 14th power plus the next term is to square this 4x to the 21 power over 3 and so on. Now what we are caring about is the first 3 terms, and so 1, 2, 3. So when we combine those, when we think about the distribution, it becomes 14 x to the 16th power plus 28 x to the 13th power, 28 x to the 20th power plus and so on, right? And so we are asked to calculate only the first 3 terms. So 1, 2, 3, and those are exactly the same, but this one is a lot easier. And I think the author of the Newton Alta may have thought something different, but to solve the problem easier, I think this way will be better. But I'm not sure whether when it comes to the exam, whether the exam problem will ask you to use other particular method by relating this one with the integration and then differentiation, which is not really effective method. So I think it is better to know both methods. The second problem is pretty similar in nature. I think what the Newton Alta's author was thinking was a similar method, just to relate that with the integration, and then we would get sine function only, and then differentiate it, and then by chain rule we will come back to this one, and that is detour. So I would recommend you just for the problem solving purpose, we will just use the expansion of sine. So sine of x equals summation k equals 0 to infinity -1 to the k power over 2k plus 1 factorial x to the 2k plus 1 . So what I will do will be f of x equals -30 x to the 4th power sine of 3 x to the 5th power. And this one will be kept. And for this part, we will use this Maclaurin series formula, and then we will expand that out. So -30 x to the 4th power, instead of x, I will replace x by 3x to the 5th power times -1 to the kth power over 2k plus 1 factorial times x is 3x to the 5th power, 2k plus 1, right? So it is summation k equals 0 to infinity. So that is negative 30 x to the fourth power. I will just put k equals 0, 1, 2 in an orderly manner. 0 power 2 times 0 plus 1 factorial times 3 times x to the fifth power 2 times 0 plus 1 plus and then negative 1 to the 1 power over 2 times 1 plus 1 factorial times 3 times x to the fifth power 2 times 1 plus 1 plus we have to find first the three terms in the Maclaurin series. And so 0, 1, and then 2. So negative 1 squared over 2 times 2 plus 1 factorial times 3 x to the fifth power 2 times 2 plus 1 and so on, right? So let us see what's going on here. Then it becomes negative 30 x to the fourth power. This will become 1, this one will become 1, and the 1 power. So 3 x to the fifth power. And then this one is 1. So plus this one is 5 factorial. So, and then 3 x to the, what is this? This is 5. And so 25 power over 5 factorial. And but I have to distribute, so 3 to the fifth power here. And then just a moment, this one is this one, and then I jumped into here, and for this one was missing, sorry. So for this one is I had to write a negative. This one is 2 plus 1 is 3 factorial times x. Here is this one is 3. So 3 cubed times x to the 5 times 3 will make 15, right? So the remaining step is you have to simplify all those things. And if you multiply this, then you can easily get negative 30 times 3 is negative 90 times x to the 9th power. Plus, if you multiply these two, we have to multiply these two, then minus will make plus. And if you simplify for this part, then you will get 135 x to the 4 plus 15 will be 19 power. And then if you multiply these two, then that is negative 9. No, it is not negative 90. It is 3 to the fifth power times 30 over 5 factorial. I think it is better to use your calculator. Then it is 243 over 4 times x to the 4 plus 25 will make 29, and so on. So alternating pattern. Any question? So calculation is messy, but as I said, the calculation themselves process is straightforward. And so you have to spend time so that you can calculate things accurately so that you don't make any mistake. So if you don't have any question, you can leave. And if you made an appointment, then you can come to the Zoom office hour session. Okay, so I will give you a quiz tomorrow.